analysis of different motions. We discuss about 3 points or 3 topics. First one is the walking of a man on a horizontal plane. Second is the flight of birds. How do birds fly? Third is horse and cart problem. Similar is the case for the motion of a hand-pulled rickshaw. So we first discuss about the walking on a horizontal road. When a person walks on a road, suppose a person is walking on a road, he forces the ground downwards with a force F in this direction. This is a kind of oblique force given by the man onto the ground. Now why does he give this force obliquely? So that he can move forward. We are going to discuss about this thing. So if the man presses the ground with the force F in the backward direction, the ground also reacts back with a reaction force R just in the opposite direction to R. If we break this R into two components, suppose this is theta, this is R cos theta known as the horizontal component H and the vertical component V as R sin theta. What does R sin theta do? Now R sin theta, it balances the weight of the man. Now we all know weight acts in a vertically downward direction always. This is mg. So we can write that R sin theta is equal to the weight of the man, or rather mg. The second component, or R cos theta, is the force which is used by the man to move forward. So R cos theta is the force component used to move forward. Now what happens when friction comes into play? If we take friction into consideration, then when the person forces the ground in the backward direction to move forward, the frictional force comes into play in the forward direction. Now this frictional force, or the amount of friction acting between the feet and the ground, determines the value of R cos theta. That means the maximum value of R cos theta cannot exceed the frictional force, because if R cos theta exceeds the frictional force, then the person will not be able to hold his balance. If the frictional force, as the frictional force is very low on a smooth surface, it is not possible to exert a large force. If the horizontal component of this force becomes larger than the frictional force, the man will slip. So we can explain it like this. If we break this F into two components, F cos theta and F sin theta. So F cos theta and R cos theta is the reaction component of F cos theta. So you can state that if R cos theta exceeds frictional force, or rather F cos theta exceeds the frictional force, because the frictional force will act in the forward direction. If R cos theta exceeds frictional force, a man will slip, as R cos theta is the reaction component of F cos theta. Now moving on to the next topic, it is the flight of birds. For the birds to fly, or the bird intending to fly, it has to flap its wings in this direction, downward direction, and the resultant of this action, it gets back as reaction C. So he or she applies the force A and B, and the resultant of these two forces, or the force applied by the bird with its wings on air, is felt back as reaction force C. So the reaction forces of B will be around this direction, reaction force of A will be around this direction. We name it as E and D. So D is the reaction force of B and E is the reaction force of A, and C is the resultant reaction. The third one is, we discuss an important topic, the horse cart problem. Now this is the cart, this is the position of the horse, this dot is the position of the horse. Now horse exerts a force F similar to the man walking on the road. It exerts a force F obliquely in the reverse direction, the reaction force acts in the forward direction. Now same thing, reaction force is divided into two components, one is V, another is H. The tension force with which the horse pulls the cart is T. So here the T acts in just the opposite direction. So what is the function of this force H, or the component or the horizontal component of R? Now H pulls the cart forward and V balances the weight of the horse. V balances the weight W of the horse. Now what is W? It is the weight of the horse. The horizontal component H helps the horse to move forward. Now let mass of horse is small m and the mass of the cart is capital M, and F be the frictional force. Now the condition for horse to move forward. What is the condition of the horse to move forward? Now the force exerted by the horse in the horizontal direction is H to move forward, and the force with which it pulls the cart is T. So for the horse to move forward, this force H must be greater than the force T. So we write H greater than T. Now net force is equal to H minus T. As H is greater than T, that means the net force is acting on the horse, that is H minus T. Now this force helps the horse to move forward, that means H minus T is equal to MA. Now A is the acceleration of the horse. Similar is the case with the cart. Now what is the condition for the cart to move forward? Condition of cart to move forward. Here the force is T and the frictional force acting on the cart is F. So for the cart to move forward, this pulling force T should be more than this frictional force. So T minus F, this is the net force acting on the cart, and if the cart is moving, that means it has started to move, that means with an acceleration, it becomes equal to MA. Now the acceleration should be same for both. If the string is tight here, so the horse's acceleration and the cart's acceleration must be the same. Now solving these two equations, H minus T is equal to MA, first equation, and T minus F is equal to capital MA, we get A is equal to H minus F by M plus M. And you can also find out the value of T, but that is not asked in the examination. They ask to find the value of acceleration of the cart or the horse cart problem. Now from this value of acceleration, if they ask that what is the condition for the system to move forward, that means H should be more than F. That means the horizontal component must be greater than the frictional force. So H must be greater than F for system to move. The individual masses capital M and small m, they are not significant, but the sum of the masses M plus M is very significant. That matters. Point number 2, the rickshaw will start moving. I have said already. I'm sorry, the rickshaw means the horse cart. The horse cart will start moving if it is H greater than F, and H less than F. That means system will not move. System will not move.